What if the future is not completely hidden? What if the strangest time paradox does not prove that time travel is impossible, but hints that the future might already be visible in ways most people never notice? Tonight, this journey explores one of the most fascinating mysteries in physics: if time can bend, stretch, and loop, then could the future already be written into the fabric of reality? And if so, is it possible that humanity has been looking at clues all along without realizing it? If this kind of science mystery is exciting, please like the video, subscribe to the channel, and share it with someone who loves cosmic questions and strange ideas. Thank you so much for watching and for supporting the channel. And before we begin, it would be wonderful to know what time is it where you are right now, and where in the world are you listening from now? Settle in and let us begin the video. If time travel is ever possible, the first mystery does not begin with a machine, a laboratory, or a tunnel in space. It begins with an absence. Across all the crowded cities, all the cameras pointed at streets and skies, all the observatories watching the universe with patient attention. There is no clear sign that anyone has arrived from centuries ahead. The question sounds almost playful at first, the kind of thought experiment that belongs in late-night conversations and speculative films. Yet the more calmly it is examined, the more unsettling it becomes. A future civilization with the power to cross time would not merely hold a new invention, it would hold access to every age that came before it. It could step into wars before they start, stand beside the birth of ideas now taken for granted, watch empires harden and dissolve, witness extinct species still living, and see long vanished skies with its own eyes. If such a power ever appears anywhere in human history, then this present era should already sit inside its reach. That simple logic gives the puzzle its force. If tomorrow's world learns to move backward through time, then today should not be empty. This age should be thick with visitors, even if strict laws surround the practice, even if only a tiny fraction of future people are allowed to travel. The number across long spans of history would still seem hard to hide. Time itself would become a road with traffic flowing in both directions. Museums would be impossible to secure. Ancient mysteries would attract crowds. Disasters would draw silent witnesses. Great discoveries would never remain private. Every turning point in history would become a destination. Yet the ordinary flow of life appears to continue without obvious interference. Airplanes cross the sky, nations rise and struggle, telescopes discover strange worlds around distant stars. Human beings build new tools and repeat old mistakes. Nothing in this surface picture clearly reveals a parade of watchers from ahead. This is where the question deepens. It is not merely asking whether time travel can happen. It is asking what kind of universe would allow it and still appear untouched. The first answer is blunt. Perhaps time travel simply cannot exist. This is the most conservative possibility, and for many people it remains the most convincing. Time seems to move one way. Lives unfold in that direction. Causes come before effects. Broken cups do not leap from the floor and reassemble themselves. Smoke leaves a fire and drifts outward, never gathering itself back into wood. Memory points backward, not forward. Biology, weather, decay, and history all appear to march along the same arrow. In daily life, the idea of reversing that arrow feels not just difficult but deeply wrong. It seems to press against the grain of existence itself, and yet modern physics weakens that confidence. The old, comfortable picture of time as a universal river flowing identically for everyone has already been broken. In the early 20th century, Albert Einstein helps change the structure of the problem by showing that time is tangled with space, motion, and gravity. Clocks do not all agree. A moving clock and a still clock do not measure the same duration. A clock deeper in a gravitational field runs differently from one farther away. Satellites orbiting Earth must account for these distortions or their navigation systems drift. Time, in this sense, is not a rigid stage behind events. It bends, it stretches. It can run at unequal rates for different observers. This is not fantasy. It is measured reality, corrected for in technology that guides aircraft, maps roads, and times signals. The world already lives inside a universe where time is stranger than instinct suggests. That is where the missing visitors become harder to dismiss. If physics already permits time to behave in flexible ways, then the forbidden boundary between impossible and merely unachieved becomes less secure. There is no need, at first, to imagine a machine from fiction. Time travel into the future already happens in a limited but real sense. Astronauts moving at high speed and living in weaker gravity age by amounts slightly different from people on Earth. The effect is small, but it is real. The path into the future is open, even if only by fractions too tiny to feel. Once that crack appears, imagination presses against it. If time can shift, could it someday shift far more? Could extreme gravity, enormous energy, or hidden structures in space-time allow a return path as well? The question no longer sounds like pure myth. It becomes an engineering problem surrounded by impossible numbers and dangerous unknowns. Still, the empty present remains. That emptiness has inspired several possibilities, each stranger than the last. Perhaps future civilizations do exist, but time travel works only forward, never backward. In that case, the paradox disappears. One can leave the present and drift toward later centuries, but no one can ever come home to an earlier age. The road has only one lane. This idea keeps the known asymmetry of time intact while preserving some room for speculation. It also carries a quiet cruelty. A traveller who leaps ahead would abandon everything familiar forever. Time travel would become a one-way exile, not a round trip. That kind of future might exist, but it would not explain away the deeper longing behind the idea, because it still denies the power to revisit what has already been lost. Another possibility is that backward travel exists, but only under conditions so narrow that almost nobody uses it. The machine may require impossible energies. It may depend on structures such as wormholes, hypothetical passages through space-time that have never been observed in nature. It may need exotic matter with properties not known to exist in stable amounts. It may operate only across short intervals, preventing visits to remote centuries. It may be so dangerous that most societies ban it, or so expensive that only rare experiments ever occur. The absence of visitors would then mean not that time travel is impossible, but that it is barely possible, more like balancing a mountain on a needle than boarding a train. Then comes a more disquieting thought. Perhaps visitors do arrive, and the problem lies in what counts as evidence. Popular imagination expects a dramatic entrance, a machine glowing in the night, a witness left trembling beside some impossible device. But a traveller with knowledge of history would know exactly how to avoid notice. Such a person would know what clothing blends in, what places are unmonitored, what moments vanish into the noise of ordinary life. The modern world is flooded with images, but it is equally flooded with error, hoaxes, misunderstandings, and overlooked details. A genuine anomaly might sink into that sea and disappear. A visitor might appear not as a spectacle, but as a person who stands in the wrong photograph, asks oddly precise questions, or departs before memory fixes the face. Time travel, if real, might leave evidence that always looks too small to matter. There is an even stranger version. The universe may allow travel, but not interference. Future observers may be present only as hidden witnesses, unable to touch the past strongly enough to change it. They would become something like ghosts of causality, physically real yet locked behind the glass of history. They could watch the building of cities, the turning of battles, the first steps on the moon, the opening of telescopes, but they could not speak in a way that matters. If so, the silence of the present does not disprove their presence. It may be the very sign of the rule that confines them. The missing visitors therefore create a paradox before any machine is built. A future with time travel should spill into the past. The past does not appear spilled into. Either the door never opens only one way, opens rarely, or opens under laws so severe that every visitor passes unnoticed or powerless. Each answer protects logic for a moment, but each answer also enlarges the mystery. The question starts as a casual challenge to science fiction, then quietly becomes a test of how reality organizes cause, memory, and possibility. If no one from the future stands plainly in the present, that absence may mean far more than a failed invention. It may mean the universe is guarding a boundary, or it may mean the boundary is already crossed so carefully that no one living inside history can tell the difference between a world untouched and a world expertly revisited. The puzzle grows sharper once the ordinary idea of time begins to fail. In common experience, time feels clean and obvious. It seems to be a single stream shared by all things, carrying every event from what has already happened into what is happening now and onward into what has not yet arrived. Morning becomes afternoon, childhood becomes age, stars rise and vanish, and each moment seems to replace the last in strict order. This picture is so deeply built into human thought that most language quietly depends on it. The past feels fixed, the present feels vivid, and the future feels open. Yet physics does not preserve this simple arrangement. The deeper the universe is examined, the less secure the familiar sequence becomes. Time does not stand outside the world like a perfect metronome. It is woven into the world, and when space bends, motion changes, or gravity deepens, time changes with them. What seems absolute from inside daily life becomes conditional under the wider rules of nature. This is where the mystery begins to turn. The question is no longer only whether a machine could cross centuries, it becomes harder and more unsettling. What exactly is a century, if time itself does not pass in the same way for all observers? Einstein's work breaks the old confidence in a universal present. Before that break, it is easy to imagine that there is one shared now spread across the cosmos like a flat invisible sheet. On that sheet, every star, planet, and living being exist together in the same moment, even if separated by impossible distance. Relativity removes that comfort. Two observers moving differently do not always agree about which distant events are happening at the same time. Simultaneity, the sense that this moment is truly the same moment everywhere, begins to dissolve. Something judged present from one frame of motion may be judged earlier or later from another. This does not mean reality becomes chaotic. It means reality is structured in a way stranger than instinct expects. Time and space are not separate containers. They form a combined fabric, often called space-time, where location and duration cannot be fully disentangled. To understand why this matters, it helps to stay close to concrete things. Light travels at a fixed speed in vacuum. This fact lies at the center of the transformation, because light takes time to travel. Seeing anything is already seeing it with delay. The moon is seen as it was a little over a second ago. The sun is seen as it was several minutes ago. A distant star may already be gone while its older light continues to arrive. Large telescopes do not look outward alone. They also look backward. The James Webb Space Telescope, the Hubble Space Telescope, giant instruments on Earth from the European Southern Observatory and other observatories all rely on this quiet truth. The more distant the target, the older the view. In an ordinary sense, the universe is already full of natural time travel, not by moving bodies through time, but by sending information across it. Astronomy becomes an archive of vanished states. A galaxy seen at enormous distance may appear as it existed billions of years before Earth formed the life that now studies it. This fact does not create paradoxes, but it does something equally important. It erodes the feeling that all of reality exists in one immediate present. There is no direct view of the universe as it is right now everywhere at once. There is only a pattern of delayed messages arriving from different depths of the past. Even the world close at hand lives under milder versions of the same rule. Lightning flashes, and thunder arrives later. A moving train is seen where it was a fraction earlier. Delay fills perception. The present is already less immediate than it seems. Relativity presses further. Time itself is affected by speed. A clock moving very fast relative to another clock ticks more slowly from the viewpoint of the slower one. This is not a trick of broken instruments. It has been measured with high precision. Atomic clocks flown on aircraft and carried on satellites disagree, by tiny predictable amounts, with clocks that remain on Earth. Particles created in the upper atmosphere survive longer when racing toward the ground at high speed, because from Earth's frame their internal processes are slowed by motion. Muons, unstable particles that should vanish too quickly to reach the surface in large numbers, arrive because relativity lengthens their apparent lifetime. The effect is not philosophical, it is physical. Processes slow, durations stretch, time becomes elastic under motion. Gravity does something similar. A clock deeper in a gravitational field runs more slowly than one farther away. This too is tested and used. Global navigation systems depend on correcting both the speed effect and the gravity effect. Without those corrections, positions on Earth would drift into useless error. Modern life quietly works because relativity is true. Cars find roads and aircraft navigate because time is not uniform. The old intuitive clock has already been replaced, not in theory alone, but in the practical operation of everyday technology. Once that is accepted, the old objection to time travel begins to weaken. It remains true that these real effects carry bodies into the future, not into the past. An astronaut on a fast journey returns slightly younger than those who remain behind, but no one arrives before departure. The so-called twin effect, made famous in thought experiments, reveals asymmetry through acceleration and changing frames, not a magical reversal. Still, the fact matters because it proves that time is not an untouchable background. It can be stretched. It can be accumulated unequally. Two people can leave a shared moment and reunite having experienced different amounts of time. The future is not reached at the same pace by all paths. In that sense, a controlled drift toward the future is already part of known physics. The present becomes less like a universal surface, and more like a route through curved terrain where different travellers log different distances. This leads to one of the most unsettling philosophical shadows cast by relativity. Though it grows from mathematics more than from speculation, if past, present, and future are all locations within a larger spacetime structure, then perhaps the flowing sense of now is not a fundamental feature of the universe. It may be a feature of consciousness moving along a world line, a path traced by a thing through space and time. In this view, often described in plain language as a block universe, the whole history of a life may in some sense exist at once within the larger geometry, even though experience reveals it one slice at a time. This does not prove that the future is fixed in every detail, and physicists do not treat the issue as settled metaphysics, but the image is difficult to ignore. It suggests that what feels like becoming may coexist with a deeper structure of being. If so, then the phrase seeing the future changes meaning. The future would not be unreal. It would simply lie beyond ordinary access, as a distant city lies beyond the horizon. This is where intrigue deepens. A universe with this kind of structure does not easily reject time travel as nonsense. It may still reject it physically, but it no longer rejects it conceptually. The future can no longer be dismissed as a blank non-entity. It becomes a region of space-time not yet reached by the observer's normal path. The real barrier is not that the future does not exist, but that causal rules may prevent turning around inside the geometry, and causal rules matter. Relativity does not permit every path. Light cones, the allowed structure of influence around events, help preserve the order of cause and effect. A cause cannot normally send a signal outside these boundaries without demanding faster than light influence, which known physics forbids. This framework protects consistency. It keeps events from arbitrarily reshuffling themselves. But general relativity, Einstein's deeper treatment of gravity as curvature, also allows mathematical solutions strange enough to reawaken the paradox. Under extreme circumstances, with rotating universes, certain cosmic strings, or wormholes held open by exotic conditions, the equations seem to permit closed time-like curves, paths through space-time that loop back on themselves. These are not proven features of reality. They are possibilities inside the mathematics, glimpsed like dark hallways in a building that may or may not physically exist. Yet their mere appearance matters. It means the laws of gravity do not automatically seal the door. They leave cracks, and once cracks appear, the missing visitor's question regains force. The more carefully time is examined, the less it resembles a one-dimensional conveyor belt. It behaves more like terrain shaped by mass, motion, and geometry. Some regions may be gentle slopes, some may be steep wells, some may be forbidden folds. Human beings experience only a narrow, biologically stable corridor through this terrain, which is why ordinary life feels smooth and one-directional. Memory records one side of the corridor. Entropy, the tendency toward increasing disorder in closed systems, seems to align with that direction as well, reinforcing the psychological arrow of time. Broken things remain broken. Ash does not become wood. Heat spreads. The universe on large scales evolves from hot, dense beginnings toward broader and more diffuse states. All of this strengthens the sense that time only advances. But thermodynamic direction is not exactly the same as geometrical possibility. One describes how systems tend to behave statistically. The other describes how space-time itself may be organized. The two arrows appear married in experience, yet they are not identical ideas. In that gap, speculation takes root. A world can obey irreversible processes and still contain rare geometries where history folds. A river can run downhill and still pass through whirlpools. That thought remains uncertain, but uncertainty is enough. It keeps the door open a fraction wider than instinct would prefer. The paradox of missing visitors therefore changes form. At first it sounds like a challenge to fantasy. Now it begins to look like a challenge to a universe already known to treat time as flexible, unequal, and inseparable from space. If time is not universal, if the present is not absolute, if the future can be approached at different rates, and if the equations of gravity permit strange loops at least on paper, then the old certainty collapses. Time remains lawful, but it no longer remains simple. The stage has not merely darkened, it has tilted, and once the stage tilts, the next fear follows naturally. If time is part of the structure of reality rather than a background clock, then paradox is no longer a literary invention. It becomes a fault line running through the foundations of cause itself. Once time is no longer treated as a simple forward flow, paradox enters almost immediately. It does not arrive as a decorative puzzle or a clever trick of language. It arrives because cause and effect, the quiet framework beneath all ordinary explanation, begin to pull in opposite directions. Every event usually depends on something earlier. A seed grows because it was planted. A war begins because tensions rise. A person speaks because thoughts form and breath follows. Human understanding depends on this order so deeply that it is almost invisible. The mind expects causes to stand behind events like footprints behind a walker. But when backward travel is introduced, the footprints can begin to circle the walker, cross in front, or erase themselves. That is why time paradoxes feel so disturbing. They do not merely challenge practical intuition, they threaten the possibility of a coherent history. The most famous of these problems is often called the grandfather paradox, but the title hides how broad the issue really is. The usual version is simple. A traveller moves into the past and prevents the existence of one of the ancestors required for that traveller's own birth. The story often selects a grandfather because the image is vivid and easy to grasp, yet the identity of the ancestor does not matter. The structure is what matters. If the traveller succeeds, then the traveller is never born. But if the traveller is never born, then the journey never happens. If the journey never happens, then the ancestor survives, and the traveller is born after all. The loop does not merely confuse, it destroys the stable order by which one event leads to the next. The cause removes the effect, and the effect removes the cause. Logic begins to spin in place. What makes this paradox so durable is that it is not really about violence or ancestry. It is about any act that erases the conditions needed for itself. If a person returns to the past to stop a fire that later inspires a career, or to remove a scientist whose work makes time travel possible, or to prevent a political event that eventually motivates the trip, the same structure appears. The details change, the contradiction remains. This is why the paradox feels larger than the simple question of whether someone could harm an ancestor. It asks whether the past can be altered in a way that severs the chain leading to the alteration. In a universe where backward time travel is allowed freely, such acts seem possible in principle. But in a universe where such acts are possible, coherence itself begins to fail. There is another classic form, often linked to the idea of killing Adolf Hitler before he rises to power. This version is more historically loaded, but its deeper importance lies elsewhere. It expands the scope of the paradox from a private family line to the entire structure of world events. The imagined traveller seeks to remove a monstrous figure before catastrophe unfolds. At first glance, the moral desire behind the scenario makes it feel simpler than the ancestor case. But that simplicity quickly collapses. If the traveller succeeds, then the world that produced the traveller's mission no longer exists in the same form. The war changes or vanishes. The horrors that justified the journey are altered or prevented. The technologies accelerated by wartime pressures may emerge differently or later. Political boundaries shift. Scientific programs diverge. Entire family histories change. In some versions, the very invention that makes time travel possible might be delayed or never appear. Once again, the act threatens the reason for itself. If the mission removes the future that sent the traveller, then what remains to send anyone back? The scale widens, but the problem is the same, because reaches backward and cuts the ground from beneath itself. These paradoxes are often called consistency paradoxes because they create histories that cannot remain self-consistent. A timeline that includes both the successful prevention of an event and the later decision caused by that same event seems unable to stabilize. It asks reality to contain incompatible truths at once. The event both happens and does not happen. The traveller both exists and does not exist. The machine is both built and never built. Ordinary logic has no room for such states in the same chain of events. That is why the paradox is not solved by calling it confusing. Confusion is what a mind feels when a stable pattern is missing. The deeper issue is that no clear pattern survives, yet even here, the situation is stranger than it first appears, because paradox does not necessarily mean impossibility. It may instead mean that the imagined freedom of action is false. That possibility comes later. Before reaching it, the paradox must be allowed to deepen. The more concrete version that moves closest to physics arrives in a scenario proposed by the theoretical physicist Joseph Polchinski. Its elegance lies in replacing human motives with a billiard ball. A ball is sent through a wormhole, a hypothetical bridge in space-time, and emerges in the past just in time to collide with its earlier self. If the older version strikes the younger one in exactly the right way, it could prevent the younger ball from entering the wormhole, but if the younger ball never enters, then the older ball never emerges to cause the collision. The paradox returns in stripped mechanical form. No emotions are involved. No historical complexity clouds the structure. Matter alone is enough. A simple object on a simple path becomes impossible to describe consistently if one version of it can obstruct the other in just the wrong way. This thought experiment matters because it drags paradox out of storytelling and into the language of physical systems. It suggests that the problem is not tied to dramatic human choices. It is built into the geometry of backward influence. Physicists who studied variants of this problem found something revealing. Not every collision creates contradiction. Many possible paths allow the older ball to strike the younger one in a way that alters its course, but still guides it into the wormhole, producing the very collision that already occurred. The system can settle into self-consistent solutions. The ball does not have to miss itself entirely. It only has to interact in a way that preserves the loop rather than erases it. This is a subtle but important shift. The paradox does not show that time travel instantly destroys logic in every case. It shows that only certain kinds of intervention do so. A closed loop in time may survive if events arrange themselves so that the outcome is compatible with its own history. This is both reassuring and eerie. Reassuring, because it hints that physics might rescue consistency. Eerie, because it implies that freedom inside such a loop may be less than it appears. The troubling part is not merely contradiction. It is the suggestion that all allowed actions may already be constrained by the need to avoid contradiction. In that view, one does not choose from all imaginable acts. One only finds oneself enacting the narrow subset that keeps history intact. The grandfather paradox is then transformed from a proof of impossibility into a warning about hidden restrictions. The traveller may aim the weapon, but some failure intervenes. The crucial encounter is missed. The machine malfunctions. The attempt changes details but not the essential outcome. History flexes, but only within limits. This idea is not yet an answer. It is a hint of one. Before that answer is examined, the paradoxes must be understood for what they reveal about the shape of time. They reveal that the past cannot be treated as ordinary territory. In physical space, a person can walk back to a location and repaint a wall or move a chair, and the consequences ripple forward in straightforward ways. But if a person walks back into time, the past is not just a place. It is the source of the very person doing the walking. It is not external to the traveller. It is constitutive. The past builds the agent who later returns to interfere with it. That makes time fundamentally different from space. Even inside a four-dimensional model, one can revisit a room without changing the fact of one's existence. One cannot casually revisit the events that generate one's existence without striking the support beams of identity and causation. In this sense, the consistency paradoxes reveal something profound. They show that backward time travel is not just motion plus earlier dates. It is intervention inside the conditions of one's own becoming. That is why the universe may resist it so fiercely. There is also a psychological layer to these paradoxes that makes them difficult to let go. Human beings often imagine the past as something that could be corrected if only access were possible. The fantasy of return is tied to regret as much as curiosity. Great tragedies, private mistakes, lost lives, missed opportunities, all invite the thought that a door backward would repair what forward time refuses to restore. The grandfather paradox and the Hitler scenario strike at that fantasy by showing that correction is not simple repair. It may unravel the web that produced the corrector. Even benevolent intervention becomes dangerous once causes fold into themselves. The dream of fixing history turns out not to be separate from the structure of identity. To change enough would be to erase the one who chooses the change. That does not prove the dream false, but it makes it unstable. A world where the past is editable is not a world where selfhood remains untouched. The paradoxes, therefore, do more than entertain. They expose the hidden price of treating time like a landscape open to revision. They show that history is not only a record of events, it is a support structure for every present observer. Remove enough beams and the observer vanishes with the building. Yet the mystery continues because physics does not simply laugh the paradox away. Relativity admits strange geometries. Thought experiments uncover self-consistent loops. Mathematics refuses to close the case. The contradictions are severe, but they do not force only one conclusion. They force a choice among unsettling possibilities. Either backward time travel is impossible in reality no matter what the equations suggest, or it is possible only under rigid self-preserving constraints, or it works by changing not one's own history, but some other branch of events. All of these answers lie ahead. For now, the paradox remains in its rawest form. A traveller reaches into the past to change a cause, only to discover that the cause holds the traveller in place. The more forcefully one pulls, the more reality seems to tighten around the knot. Time no longer looks like a river that can be sailed in reverse. It starts to look like a web, and every thread leads back to the hand that tries to move it. The paradox becomes more unsettling once it is stripped of emotion, memory, and history, and reduced to matter moving through geometry. Human stories carry too many motives, too many moral shadows, too many possibilities for distraction. A machine can fail. A person can hesitate. A memory can be wrong. But a simple object moving along a defined path is hard to argue with. If contradiction appears there, it appears close to the skeleton of physics itself. This is why wormholes and closed paths through space-time matter so much to the idea of time travel. They take the question away from imagination alone and place it inside the mathematical architecture of general relativity, where space and time are no longer separate stages but a single curved structure shaped by mass, energy, and motion. A wormhole, in its simplest speculative description, is a shortcut through space-time, a tunnel linking distant regions that would otherwise be enormously far apart. The image often used is crude but useful. If space-time were a sheet, two distant points on that sheet could be brought near by folding it, and a passage between them could join what would normally remain remote. The idea first appears in serious physics in work associated with Einstein and Nathan Rosen in the 1930s, where certain mathematical solutions hint at bridge-like structures. In later decades, the concept becomes one of the most famous examples of how relativity can generate strange possibilities without guaranteeing that nature actually realizes them. The equations open a door on paper. Whether the universe has built the door in stone is another matter entirely. The immediate attraction of wormholes is spatial. A shortcut across huge cosmic distances would already be extraordinary. It would suggest that the universe hides routes more efficient than ordinary travel through open space. Yet the deeper intrigue appears when time enters the picture. If one mouth of a wormhole experiences time differently from the other, perhaps through high-speed motion or intense gravity, the two ends can become out of sync. In principle, one opening may age less than the other. If the tunnel joining them remains intact, stepping through could connect not only different places but different times. A traveller entering one side might emerge when the other side stands in an earlier year, relative to the departure point. That is where speculative space shortcut becomes speculative time machine. The logic is subtle enough to feel almost accidental. No great reversal of the whole universe is required. All that is needed is a stable bridge and a mismatch in elapsed time between its ends. The elegance of the idea makes it dangerous to dismiss too quickly. It is not born from fantasy alone. It grows from the very relativity that already tells clocks to disagree. But the word stable hides the real abyss. Wormholes, if they exist at all, do not appear easy to keep open. Many solutions suggest that a traversable wormhole would collapse too fast for anything to pass through unless supported by exotic matter, material with unusual energy properties, unlike anything known in ordinary bulk form. Quantum theory permits strange local effects in some contexts, such as the Casimir effect, where energy conditions can behave in ways that feel counterintuitive. But scaling such phenomena into a giant tunnel through space-time remains deeply speculative. No laboratory has produced a useful wormhole. No telescope has clearly seen one. No mission from NASA, ESA, or any major observatory has confirmed a structure that can be identified as a traversable bridge between distant regions of the cosmos. Some researchers have explored how certain lensing patterns or unusual gravitational signatures might betray exotic compact objects, but nothing definitive has emerged. The universe has not yet offered the evidence needed to treat wormholes as more than mathematically interesting possibilities. And yet the possibility remains stubborn because the equations do not immediately banish it. This is the uneasy territory where time travel lives best. It is not confirmed, not impossible, not free, not absurd. It is suspended between what the laws permit in principle and what reality may refuse in practice. Inside that suspension, the paradox sharpens. Polchinski's billiard ball does more than dramatize contradiction. It reveals that a time machine need not transport complex intentions to generate trouble. A path through a wormhole can be enough. Imagine a billiard ball moving toward one mouth before it arrives. An older version of that same ball emerges from the other mouth, displaced into the past. The older ball collides with the younger one and changes its trajectory. If the collision prevents the younger ball from entering the wormhole, then the older ball never emerges to cause the collision. The contradiction seems complete. Yet when physicists examined this kind of setup more closely, they found something remarkable. There are self-consistent collisions. The older ball can strike the younger one in precisely such a way that the younger ball is deflected, but not out of the wormhole entirely. Instead, it enters at a slightly altered angle that leads it to emerge in the past and produce exactly the collision that already occurred. The loop closes without contradiction. Cause and effect still circle each other, but they do so in a pattern that survives. This discovery changes the emotional tone of the paradox. The initial version feels like a demonstration that time travel breaks logic. The refined version suggests something stranger. Logic may survive, but only by narrowing what can happen. The universe, if such a loop is allowed, does not permit every imaginable motion. It permits only those motions that fit into a self-sustaining history. The ball is not free to behave in every ordinary way. The geometry of time selects the outcomes that do not tear the sequence apart. That selection has consequences far beyond a billiard table. It implies that any real time travel system based on closed paths through space-time may operate under hidden constraints that appear almost like fate. The word fate is dangerous because it sounds mystical, but the underlying concern is mechanical. In an ordinary room, the range of possible motions is wide. A ball can roll left or right, stop or strike, rebound or miss. In a time loop, many of those options may exist only in imagination. The actual system may funnel events into the tiny set that preserves consistency. If so, the paradox becomes a sign not that history is editable, but that history is much harder than it seems, almost like hardened glass that flexes only along pre-existing lines. That possibility leads directly into one of the darkest features of wormhole time travel. A machine of this kind would not simply move bodies into earlier years. It would create regions where causal order ceases to be globally straightforward. Ordinary life depends on a clean distinction between earlier influences and later results. A closed time-like curve, the formal phrase for a path that loops back through time while remaining physically continuous, corrupts that distinction. An object on such a path can be older than itself and younger than itself depending on where along the loop it is examined. Questions that usually have clear answers become unstable. Where does a process begin? When does information first arise? Which event explains which other event? In a closed loop, beginning may not exist in the familiar sense. There may be only continuation around a circuit. This does not automatically create contradiction, but it does damage the intuition that reality must always contain an origin point for every local chain. The universe begins to look less like a line of falling dominoes and more like a pattern that sometimes closes back on itself. There is another difficulty, quieter but more profound. Even if a wormhole time machine could exist, it would not grant unlimited access to any past. If the time offset between its mouths is created after the wormhole already exists, then the traveller may be able to return only as far back as the moment the machine becomes a machine. The tunnel cannot deliver anyone into centuries before its own causal preparation, unless it had already been present and appropriately shifted across those centuries. This severely limits the fantasy of visiting any historical event at will. A civilization might construct a time machine that reaches only to its own era of construction, and later, the farther past remains sealed. In that case, the missing visitor's paradox weakens in one way and strengthens in another. It weakens because no future traveller could reach this present unless a suitable device or structure already existed near this time. But it strengthens because if such a device did come into being and remain available across generations, the later traffic backward into its accessible past could become overwhelming. History after the birth of the machine might become crowded with returns. That raises an eerie possibility. The reason this era seems empty may be not that time travel fails forever, but that the relevant door has not yet been made. The silence of the present may simply mark the stretch of history before the first anchor point exists. Still, even this limited model does not remove the deeper threat. Once a loop is possible, the whole architecture of explanation changes. Consider information carried through such a system: a design, a warning, a map, a formula, an instruction manual. Anything compact enough to survive transport could be sent into the past and used to shape the conditions that later send it back. The information would then circulate without a clear first author. It would not be created in the ordinary sense. It would persist. This is not yet the full bootstrap paradox, which belongs more centrally to the next stage of the mystery. But wormhole physics gives that paradox a plausible mechanical stage. A tunnel through space-time becomes a machine for originless persistence. Something can exist because it exists already on the loop. That idea does not merely strain common sense. It tests whether physics can tolerate causes that do not begin where human explanation expects them to. The scientific response to all of this remains careful for good reason. General relativity allows exotic structures, but physics is larger than general relativity alone. Quantum effects may destabilize any would-be time machine. Some calculations suggest that as soon as closed time-like curves threaten to form, vacuum fluctuations and runaway energy densities could grow violently enough to destroy the structure. Stephen Hawking's chronology protection idea grows from this general hope or suspicion that the laws of nature somehow intervene before paradox-producing loops become physically real. The phrase sounds almost dramatic, but the intent is sober. Perhaps the universe has a built-in way of preventing its own causal breakdown. The mathematics of gravity may open the possibility locally, while the full union of gravity and quantum behavior closes it globally. The problem is that no complete theory of quantum gravity yet exists to settle the matter. Physics sees the edge of the trap without possessing the final map of the terrain. That uncertainty keeps wormholes alive in scientific thought, not as accepted objects, but as stress tests for the laws themselves. They reveal where current understanding is incomplete. If nothing else, they show that time travel is not rejected simply because it sounds strange. It is questioned because the known laws, when pushed into extreme domains, begin to say different things in different voices. One voice says clocks can desynchronize, geometry can curve, and tunnels might bridge remote regions. Another voice says paradox cannot be allowed, causal order must survive, and quantum reality may erupt to defend it. The argument is unresolved because the universe has not yet shown which voice dominates at the deepest level. The billiard ball moving through a wormhole therefore becomes more than a toy problem. It is a compressed image of a much larger conflict. On one side stands the flexibility of space-time. On the other stands the demand for consistent history. Between them lies the possibility that reality is more selective than intuition, permitting loops only when every detail closes cleanly, or forbidding them entirely through still-hidden laws. Either answer is strange. A universe that permits such loops is a universe where the past can be revisited only along tracks that were always part of it. A universe that forbids them is a universe that lets mathematics flirt with impossible corridors while quietly sealing them off before anyone can enter. In both cases, the mystery deepens. Time travel does not look like a machine with a dial. It looks like a confrontation with the deepest architecture of cause, and the more coldly that architecture is tested, the less it resembles a story humans can control. There is a form of time paradox even stranger than contradiction. Contradiction at least announces itself as a wound in logic. It says that two events cannot both be true, that something has gone wrong in the sequence, that history has broken against itself. But another class of paradox does not break history so openly. It preserves the chain. It allows every event to fit with every other event. Nothing cancels itself. Nothing obviously vanishes. And yet, when the pattern is examined closely, something essential is missing. The chain has no first link. Cause and effect still operate, but they operate in a circle. This is the territory of causal loops, sometimes called originless paradoxes, because what appears in the world is passed from future to past and from past to future without any clear point of creation. Instead of a contradiction, there is an eerie completeness. The sequence holds together, but it floats without foundation. This may be more unsettling than an impossible timeline, because it suggests that reality can contain events that never truly begin. The predestination paradox gives the clearest first shape to this idea. In such a loop, a traveller goes back in time intending to prevent or change some event, only to become the cause of the very event that inspired the journey. The future leads into the past, and the past produces that same future. Nothing in the loop contradicts itself. Every part explains another part, but the whole pattern closes in a way that denies an external origin. The person travels because the event occurs, and the event occurs because the person travels. A decision that seems free turns out to be part of a structure already waiting for it. The trap is not that logic fails. The trap is that logic succeeds too well. Every step has a cause, yet the entire circle has no obvious beginning outside itself. The cat example from popular explanations captures this with unusual emotional clarity. A person loses an animal in a traffic accident at a particular place and time. Grief later drives a journey into the past to save it. The traveller knows the road, the corner, the fatal instant. Armed with knowledge, the traveller waits. The animal sees the familiar figure and runs towards safety. A driver swerves to avoid hitting the traveller and instead strikes the animal in exactly the way history remembers. The journey meant to prevent the death causes the death. The story is simple, almost quiet, which is why it lingers. No vast political event is needed. No machine of world-changing consequence has to be involved. A small private loss becomes a closed circuit. The attempt to intervene is woven into the event from the beginning. That is what gives the predestination paradox its peculiar force. It suggests that some histories might already contain the very efforts made to change them. What looks like resistance to fate becomes the mechanism by which fate is fulfilled. In a purely scientific sense, the word fate may be misleading, because it carries a sense of intention or cosmic design. Causal loops do not require intention. They require only self-consistency. The universe need not want anything. It need only permit only those paths through time that remain mutually compatible. Still, from within human experience, the effect is almost indistinguishable from predestination. A person acts with urgency, even rebellion, believing the future can be rewritten, only to discover that the action belongs to the very story it was meant to erase. The future does not block the intervention, it absorbs it. This possibility transforms the meaning of knowledge. Normally, knowing more about an event grants greater control over it. In a causal loop, perfect knowledge may change nothing essential, because the act of using that knowledge is already part of the known event. The more accurately one tries to avoid the outcome, the more precisely one may step into it. That inversion is one reason time travel stories built around predestination feel unnerving long after the details are forgotten. They reflect a scientific puzzle, but they also touch a deeper fear that the line between choice and structure may be thinner than it seems. If the predestination paradox concerns events, the bootstrap paradox concerns things, especially objects or information. Here the loop closes not around an accident or a decision, but around an artifact. A person receives a book explaining how to build a time machine. The instructions are followed. Years later, the machine is completed. The builder then travels back and delivers the same book to the earlier self. The book, therefore, has no identifiable author in the ordinary sense. It exists because it is carried around the loop. The information inside it is never composed from scratch inside the timeline. It simply persists. This is the bootstrap paradox, named for the absurd image of pulling oneself upward by one's own bootstraps. The object or the knowledge seems to bring itself into existence. Once again, there is no contradiction if every step matches every other step. The book is present in the future because it was present in the past, and present in the past because it was present in the future. The loop closes neatly, but the question remains: who wrote the book? Where did the information originate? What first act created the pattern? Inside the loop, there is no answer. The information exists, but its origin is missing from the chain. This is what makes the bootstrap paradox so difficult to dismiss. Human explanation is deeply attached to origin. A painting comes from a painter. A theory comes from a mind. A tool comes from design and labour. Even when the chain of influence is long, some earlier stage of emergence is expected. The bootstrap paradox denies that comfort. It offers a world in which the local sequence of causes is complete, while the global emergence of the thing remains absent. The object is not eternal in the broad sense. It may decay, circulate, and disappear outside the loop if the loop is ever broken. But while the loop holds, the object does not need a first moment of invention. It survives by recurrence. This sounds like fiction, until physics itself begins to flirt with structures that could host such a pattern. Wormholes, closed time-like curves, and self-consistent causal loops provide at least a formal stage on which originless information might move. A formula, a blueprint, a warning, a melody, a fragment of code. Any sufficiently compact pattern could in principle circulate through time if a closed path existed. The deeper question is whether the laws of nature can tolerate such a thing. Can information exist without being authored at some first point in the timeline? At first glance, the answer feels like no, because the mind treats creation as necessary. Yet physics is not built from intuition about authorship. It is built from lawful relationships between states. If every state along the loop leads lawfully to the next, the system may not care that the broader pattern lacks the kind of beginning human storytelling demands. That possibility is both liberating and disturbing. Liberating, because it shows that time may be more flexible than inherited common sense allows. Disturbing, because it suggests that some fact about the world might be true without ever having been discovered in the usual forward-moving way. The paradox then moves from narrative curiosity to epistemological threat. Knowledge itself becomes strange. In ordinary scientific practice, an idea is generated, tested, corrected, preserved, and handed forward. In a bootstrap loop, an idea may arrive from the future already finished, with no discoverable moment of invention within the accessible timeline. This does not merely change history, it changes the meaning of explanation. One may understand how the information survives, yet not how it is born. The loop replaces genesis with circulation. There is also a physical cost hidden beneath the elegance of these loops. Objects and information are not abstract symbols alone. They are embodied in matter. A book ages, ink fades, paper yellows, a machine wears down. If the same object literally travels the loop over and over, then each cycle imposes damage. Unless repairs are made within the loop, the object cannot remain identical forever. This detail has prompted some thinkers to argue that bootstrap paradoxes involving physical items are less stable than they appear. The book may be recopied, the message may be reprinted, the design may be preserved in new material each time. But once copying enters the story, the clean image of the exact same artifact circling forever begins to blur. That does not destroy the paradox. It merely shifts it from matter to pattern. What remains originless is not necessarily a single physical object, but the information encoded within it. Even then, entropy casts a shadow. If a message must be recopied with high fidelity across repeated loops, errors can accumulate unless some mechanism of correction exists. This introduces an intriguing tension between time travel and the thermodynamic arrow of time. Causal loops seem geometrically allowed in some speculative frameworks, yet the physical world still tends toward wear, noise, and drift. A perfect loop may therefore be harder to realize materially than it is mathematically. The universe may tolerate originless patterns only under fragile conditions. That fragility makes them more mysterious, not less. They would be like stable whirlpools in a river otherwise committed to flowing onward. Predestination and bootstrap paradoxes differ in focus, but they share a common lesson. The past may not resist change by becoming unreachable. It may resist change by already containing the attempt. The future may not be absent from the past. It may already be folded into it. This thought changes the emotional atmosphere around time travel. Earlier paradoxes make backward travel seem dangerous because it threatens contradiction. Causal loop paradoxes make it seem uncanny because it threatens novelty. A traveller may act, but the action may never introduce anything genuinely new into history. It may only complete patterns already present. This possibility places a limit not just on intervention, but on creativity itself. One can imagine a composer receiving a melody from the future, publishing it, and later sending it back as the source of the same composition. The melody exists, is heard, admired, and preserved. But no one truly composes it in linear time. Or a scientist may inherit a proof from an older self, publish it, then decades later carry it back to the younger self who first received it. The theorem is valid, the chain is complete, yet the act of invention dissolves into the loop. Science fiction often treats such examples as intellectual games, but they point toward a deeper issue. Human culture depends on the belief that ideas emerge through discovery. Remove the emergence, and culture begins to feel haunted by its own future. The loop also raises questions about identity. If a person becomes the cause of a defining event in the earlier self's life, then the self is in part self-authored through time. This is not the ordinary sense in which choices shape character. It is far stranger. The older person literally enters the younger person's history as a formative cause. Identity folds over itself. An adult may influence the childhood event that later produces the adult. The self becomes one of its own ancestors. Again, no contradiction is necessary. The story may be perfectly self-consistent, but it empties out the usual notion of a linear life. Personal history becomes circular rather than developmental. This does not prove such loops exist. It reveals what kind of reality would be required if they did. It would be a reality where beginnings are local conveniences, not universal necessities. The scientific impulse pushes back against this conclusion, not because it is aesthetically unappealing, but because it seems to violate deeper principles about causation and information. Many physicists suspect that some still hidden law must forbid these loops or render them physically meaningless. Quantum theory may again be the key. Processes near closed time-like curves may become unstable. Attempts to define probabilities on such backgrounds may produce pathologies. Some approaches to quantum information suggest that bizarre effects could occur if systems interact with their own past states, effects that challenge ordinary intuitions about computation, copying, and consistency. But none of this reaches a final verdict. The mystery remains suspended. On one side lies the mathematical possibility of closed causal circuits. On the other lies the expectation that the universe must somehow protect origin and prevent information from floating free of creation. Between them sits the haunting image of a world where the future does not merely visit the past, it helps write it. Causal loops therefore deepen the time paradox in a different way from direct contradiction. They do not say history collapses, they say history may be complete in the wrong shape. A circle can be perfectly consistent and still refuse the answer to where it begins. In that refusal lies one of the darkest possibilities in all speculation about time. The future might not shatter the past when it arrives, it might quietly close it. Once paradox has been allowed to unfold in full, the next question is unavoidable. If the laws of nature are as coherent as they appear, how can they permit histories that contradict themselves or loops that seem to generate information from nowhere? At this point, the mystery changes character. Earlier sections follow the traveller into danger, watching cause and effect bend until they threaten to snap. Now the focus shifts to the possibility that they never snap at all. Perhaps the true story is not that time travel breaks reality, but that reality contains hidden safeguards strong enough to prevent the break. In that case, the paradoxes are not forecasts of what would happen if a machine were built. They are warning signs showing where ordinary intuition outruns the limits of the universe. This possibility has produced several kinds of answer. ranging from speculative and almost literary ideas to more disciplined proposals rooted in physics. None has settled the question completely, but taken together, they suggest a universe that may be less permissive than the imagination hopes, and more structured than it first appears. The broadest and loosest answer is sometimes described as timeline protection. The phrase has the feel of science fiction, because it often is science fiction, and in its weakest form it says only that the universe somehow refuses changes to the past that would generate contradiction. The refusal might come through mechanical failures, chance events, barriers no one anticipates, or deeper laws that quietly block the crucial act. A traveller can reach the past, perhaps even move within it, but cannot force history into a shape incompatible with the fact that the traveller came from it. In such a world, attempts to alter key events would fail, not because the traveller lacks determination, but because reality itself is biased toward consistency. The idea sounds fictional because it usually leaves the mechanism vague, yet its appeal is obvious. It protects logic without abandoning the possibility of backward travel entirely. Time becomes accessible, but only along rails that already belong to a self-consistent history. The difficulty is that vague protection explains too much too easily. If every paradoxical attempt simply happens to fail, then the theory risks becoming a storytelling device rather than a scientific principle. To become more than that, the universe's refusal must arise from something firmer than narrative convenience. This is where the Novikov self-consistency principle enters, developed in connection with the work of Igor Novikov. This principle sharpens the loose intuition into a more exact claim. It states, in plain terms, that events on a closed time loop can occur only if they are globally self-consistent. Any event that would create a contradiction has zero probability. The phrase zero probability is crucial. It does not say such events are merely unlikely. It says they cannot happen. If a traveller goes into the past, whatever that traveller does must already be compatible with the history from which the journey departs. The paradox dissolves because the forbidden outcome is removed from the space of real possibilities. Under this principle, the grandfather is not killed before the parent is conceived, the crucial letter is not destroyed before it is sent. The billiard ball does not collide with itself in a contradiction-generating way. Only self-consistent interactions are physically realized. What makes this proposal feel more scientific than simple timeline protection is that it does not rely on mystical intervention. It relies on global consistency as a condition on the allowed solutions of physical laws. The universe does not step in emotionally to save history. History is simply the kind of structure that only certain event patterns satisfy. The traveller still acts, matter still moves, and local causation still operates. But the full space-time configuration must close without contradiction. The old image of unlimited freedom in the past therefore collapses. Time travel, if it exists under such a principle, is not a power to rewrite history. It is a power to participate in history more deeply than one realized. This has a severe consequence for the idea of choice. Within ordinary life, freedom is experienced as openness among multiple available outcomes. Under self-consistency, some of those imagined outcomes may never have been available inside a looped structure at all. The traveller may feel capable of many acts, but only the acts already compatible with the existing timeline can occur. That does not necessarily mean the traveller feels externally controlled. It may mean that every real decision inside the loop simply happens to align with what history requires. But from outside the experience, the effect looks almost indistinguishable from inevitability. This is why the principle feels both elegant and cold. It saves logic by narrowing possibility until history becomes a tightly locked design. The Polchinski billiard ball scenario gives the principle its most concrete form. The reason self-consistent collisions matter is not merely that they solve one toy problem. They reveal a model for how the universe could behave generally. A contradiction-generating collision is mathematically imaginable, but if the principle holds, the physical system never realizes it. Instead, the only allowed trajectories are those that preserve the loop. This suggests a deep shift in how causation is understood. One normally thinks of physical evolution as proceeding from earlier states to later ones through local laws. The self-consistency principle introduces a global condition. The full pattern in time constrains the local motion. In that sense, the future and the past are not linked only sequentially. They must fit together as parts of a larger geometric whole. This is unusual, but not obviously absurd within a relativistic spacetime framework, where the entire structure of events can be treated as a four-dimensional object rather than a story being written one line at a time. Still, many minds resist the principle because it feels like an assault on ordinary agency. The resistance may say more about human expectation than about the laws themselves. Physics is under no obligation to preserve the emotional version of free action that daily life encourages. Yet the unease remains. A time traveller who cannot create contradiction may also be unable to create genuine novelty. The past becomes a chamber where every step is already part of the flaw. There is another candidate safeguard, one more explicitly connected to established physics, and it carries one of the most memorable names in modern speculation chronology protection. Stephen Hawking gives this phrase a scientific seriousness that the looser image of timeline protection often lacks. The central idea is that the laws of physics may prevent the appearance of closed time-like curves before they can become usable time machines. In other words, the universe may allow equations that hint at time loops, while still arranging the actual behavior of matter and quantum fields so that such loops never form in any accessible, stable way. This is not merely a philosophical preference for neat history. It is a suspicion about the behavior of extreme spacetime itself. Near the threshold where a time machine would arise, quantum effects may become violent enough to destroy the necessary geometry. Vacuum fluctuations, ordinarily subtle and hidden, could grow without bound. Energy densities could surge. The wormhole or curved region needed to create the loop might collapse, destabilize, or seal itself before anything can pass through. In that case, chronology is protected not by metaphysical law, but by the physical back-reaction of the universe to its own dangerous configurations. This idea remains unproven, but it is powerful because it lives at the boundary where general relativity and quantum theory fail to cooperate cleanly. General relativity alone can admit strange solutions. Quantum behavior may be the force that forbids them in practice. The problem is that no complete theory of quantum gravity yet exists to show exactly how the argument ends. Hawking's proposal, therefore, feels less like a finished theorem than like a signpost pointing toward the kind of law nature might possess. It says, in effect, that the universe may detest paradox strongly enough to make time machines physically unstable. This is a subtle but important difference from self-consistency. Novikov allows loops and then constrains what can happen inside them. Chronology protection says the loops themselves may never become real in the first place. One answer accepts backward travel under rigid rules. The other attempts to outlaw it entirely at the level of physical realization. The contrast between these answers is revealing. It shows that even among attempts to rescue logic, there is no agreement about how generous the universe should be. One model imagines a tightly choreographed dance through the past. The other imagines the dance floor never appears. Both preserve consistency, but they do so by very different means. The first sacrifices freedom. The second sacrifices access. Between them lies the unresolved question of which sacrifice nature actually makes, if either. The idea of chronology protection grows more haunting when placed beside the actual history of physics. Time and again, equations have permitted extraordinary possibilities later confirmed in reality. Black holes once seemed exotic and almost absurd. Gravitational waves were long treated as remote predictions before observatories finally detected their passing distortions. Planets around other stars move from speculation to catalogued abundance. This history creates a dangerous temptation. If mathematics opens a door, perhaps nature will eventually walk through it. But the same history teaches caution. Not every mathematical possibility is physically realized. Some solutions describe idealized or unstable states. Some require conditions the universe never actually supplies. Some point to the limits of current theory rather than to real objects awaiting discovery. Time machines may belong to this latter class, not hidden structures in the cosmos, but warning markers telling physics that its deepest theories remain incomplete. If so, then paradoxes are less about future technology than about the unfinished map of reality. There is also a quieter version of protection, one that sits between hard scientific principle and narrative speculation. Perhaps the past can be visited only in ways too weak to matter. A traveller may observe but not alter anything significant. The image resembles a ghost, though not in a supernatural sense. It suggests a coupling so faint that information cannot be transferred strongly enough to rewrite history. Some interpretations of chronology protection drift in this direction, imagining that nature permits only vanishingly small effects near dangerous loops, never the robust interaction needed for paradox. This would help explain the missing visitors problem as well. Future observers could in some sense exist, but not as active participants. They would be shadows moving through an inaccessible layer of history, present without leverage. Scientifically, this remains speculative, but it reveals how many different ways the universe might preserve coherence. It can block entry, it can constrain action, it can weaken influence until contradiction never develops. Another possibility is even subtler. The universe may not need a special law of protection, because the very conditions required for time travel may already guarantee self-consistency. In other words, any physically real wormhole or loop that survives formation might automatically produce only paradox-free histories. The dangerous configurations imagined in thought experiments may never correspond to stable solutions once all fields and forces are included. Reality would then appear to protect chronology, but not by adding an extra rule. The protection would emerge naturally from the deeper unity of the laws. This is an attractive thought because nature often works that way. Apparent freedoms disappear when more complete dynamics are considered. Yet this again depends on a final theory not yet in hand. Without that theory, the protection remains an informed suspicion rather than a demonstrated fact. The emotional core of all these safeguards is worth noticing. Human beings tend to imagine time travel as liberation from consequence. One could revisit mistakes, test alternate histories, and break free from the irreversible march of events. But every serious attempt to reconcile backward travel with known physics moves in the opposite direction. The deeper the analysis goes, the more constrained the universe becomes. Possibility narrows, histories harden. Paradox is not resolved by granting more freedom, but by granting less. If time travel is allowed at all, it may be the most rule-bound phenomenon imaginable. That inversion is one of the strangest features of the whole subject. The fantasy begins with endless options and ends with a cosmos that either bars the door or makes every step inside the door predetermined by consistency. In this light, the missing visitors problem starts to look less mysterious and more diagnostic. Maybe there are no visitors because there can be none. Maybe there are no visitors because any time machine destroys itself at birth. Maybe there are visitors but they can do only what history already records and therefore leave no clean sign of intrusion. Maybe the present is silent because the universe is far more hostile to contradiction than human imagination is prepared to accept. Yet there is one more unsettling detail. Even a perfectly protected timeline does not necessarily make the future unknowable in every sense. It only protects causal order from gross violation. Within a self-consistent universe, information about later events might still leak backward under very narrow conditions, provided that leak is already part of the history it helps produce. A warning may arrive because it always arrived. A discovery may appear early because it was always carried back. Protection against paradox is not automatically protection against strangeness. The timeline may remain intact and still be threaded by loops of influence that make ordinary chronology feel haunted. This is why the safeguard theories do not end the mystery. They deepen it. They say the universe may have defenses, but those defenses may themselves produce patterns that look eerie, fated, and almost intelligent without any guiding mind behind them. Reality begins to resemble a system that not only contains events, but edits them for coherence. Whether that editing is done by hard physical law, global consistency, quantum instability, or something still unknown remains unresolved. What is clear is that the simplest fantasy of going back and changing anything one wishes does not survive contact with serious thought. The past, if reachable, is not soft clay. It is either locked stone or a mirror maze where every path curves back into what already is. And if the universe truly does protect its chronology, then paradox is not a sign that time travel will one day become chaotic. It is a sign that reality may be far stricter, far more selective, and far more mysterious than the dream of a machine ever suggested. When paradox becomes too severe for a single timeline to bear, the imagination almost automatically reaches for a second one. If changing the past destroys the future that sends the traveller, perhaps the act does not destroy anything at all. Perhaps it diverts. Perhaps the traveller does not rewrite one history but steps into another. This idea has enormous appeal because it appears to dissolve contradiction without demanding that the universe block every dangerous action. The traveller can kill the ancestor, prevent the war, save the lost life, or alter the invention, and yet the original future still remains intact somewhere else, because no longer cuts through its own roots, because the roots belong to a different branch. History splits rather than breaks. The paradox that once seemed fatal becomes a question of which timeline is being discussed. In this way, the multiverse enters the problem of time travel not merely as extravagance but as an attempt at rescue. It does not make time simpler, it makes reality larger. The first thing to notice is that the multiverse is not one idea but a family of ideas, and that matters. In popular culture, it often appears as a casual storehouse of alternate worlds, each differing from another by some dramatic twist. In science, the picture is more restrained and more fragmented. Some versions arise from cosmology, where inflationary models suggest that space may contain vast regions with different histories or conditions. Some arise from quantum theory, especially interpretations in which multiple outcomes are treated as equally real branches of a larger wave function. Some appear in string theory landscapes or in speculative discussions of the deeper structure of physical law. These frameworks are not identical, and none has delivered direct observational proof that can settle the matter cleanly. Yet the reason they continue to attract attention is that modern physics repeatedly generates situations where more than one classical picture seems to coexist beneath the surface. The universe has already taught science not to be too loyal to the visible layer of things. That does not prove alternate timelines exist. It only means the idea is not born from pure fiction alone. Once introduced into time travel, however, the multiverse becomes something very specific. It becomes a way of protecting consistency by changing the target of the intervention. Under this picture, a traveller who goes back and changes the past does not alter the exact history that produced the departure. Instead, the traveller enters another branch where events now unfold differently. The original world line still contains the departure, the motive, the machine, and the remembered past. The new branch contains the altered event and the consequences that follow. The traveller is no longer trapped in a contradiction, because the cause belongs to one branch and the intervention to another. The traveller may return, perhaps not to the home branch, but to some related future, or may remain stranded in the branch created or entered by the act. The old timeline is not erased, it is bypassed. This is an elegant solution at first glance because it preserves agency. A person can act freely in the past without the universe needing to jam every mechanism or enforce self-consistency at every turn. Contradictions vanish because there is no longer only one history whose logic must remain seamless. Yet this solution carries a price, and the price is not small. It means that saving the past does not save one's own past. It saves another version of it. The traveller who prevents a disaster may create a world where the disaster never happens, but the original world, the one from which the traveller came, still contains the loss that motivated the journey. The pain remains real there. The mission becomes less like revision and more like emigration into a different branch of reality. This changes the emotional meaning of time travel completely. The fantasy of repair turns into a passage between histories. One does not heal the wound in the original timeline. One steps into a world where the wound forms differently or not at all. To some minds, this feels merciful enough. To others, it feels like failure wearing the mask of success. The paradox is removed, but the longing that drove the journey is only partially answered. There is also a conceptual question about what exactly branching means. In everyday imagery, a timeline looks like a line that forks like a tree, but physics does not actually present time so neatly. In quantum theory, branching is often used as a way of speaking about the evolution of a wave function under decoherence, the process by which microscopic possibilities become effectively separate at larger scales. The branches are not worlds floating like planets beside one another in some obvious extra space. They're components of a broader mathematical description that no ordinary observer experiences together. Translating that into time travel is not straightforward. A time traveller does not merely step from one film reel to another, because film reels are human metaphors. The real question is whether the laws of physics allow a localized system, such as a person or machine, to move from one branch of cosmic history into another in a controlled way. That is a far stronger claim than the mere existence of branches. Modern interpretations of quantum mechanics may tolerate multiple outcomes at a formal level, but they do not automatically provide a mechanism for travel between them. This is where the multiverse solution grows hazy. It can explain how contradictions are avoided if branching exists, but it does not clearly explain how a machine selects or enters the alternate branch. Still, the idea refuses to disappear because it solves so many paradoxes at once. The grandfather paradox becomes simple. The ancestor dies in a branch different from the one that produced the traveller. The Hitler scenario becomes grim but coherent. A catastrophe is prevented in one timeline while the original one, with its war and its scars, remains the source of the mission. The bootstrap paradox becomes stranger but not impossible. Information from one branch may appear in another, though then the origin problem changes rather than vanishes. One must ask not only where the information came from in time, but from which history. The multiverse therefore relieves pressure on consistency, while opening a much larger mystery about identity, causation, and the meaning of worlds themselves. There is a cosmological version of this thought that deepens the intrigue further. Some inflationary models suggest that the early universe may have undergone explosive expansion in a way that creates enormous regions beyond observable reach. Regions sometimes imagined as separate bubble universes with different histories and perhaps different physical constants. This is not the same as branching through time, but it contributes to the atmosphere in which multiple histories become thinkable. If reality already contains vast unreachable domains beyond the observable cosmos, then the old instinct that there must be only one stage for everything begins to weaken. The universe becomes less like a single chamber and more like a structure with hidden architecture. Time travel then starts to resemble not motion against one fixed background, but navigation through a deeper maze. Even if such cosmic bubbles do exist, they do not by themselves solve time paradoxes, yet they train the mind to accept plurality on scales once dismissed as absurd. Scientific humility grows precisely where the observable horizon ends. The deeper mystery is whether hidden domains of reality are merely remote or also causally accessible under extraordinary conditions. There is another path into the same territory through black holes, wormholes, and speculative geometry. Some theorists have wondered whether what looks like time travel in one description could correspond instead to a transition into another connected region of reality. A traveller entering a wormhole and emerging into an earlier seeming state may in fact have crossed into a branch with a different ordering of events relative to the original frame. This idea remains highly speculative, but it reveals how multiverse thinking can merge with geometry. The machine does not literally move backward in one history. It exits into a neighbouring history where the local date is earlier relative to the departure branch. If so, the paradox was misleading from the beginning because it assumed one timeline where there were always many. The traveller never changes the past of the home world. The traveller departs from it. Yet the scientific caution here is severe. No mission from NASA or ESA, no observation from the Hubble Space Telescope, the James Webb Space Telescope, or the great observatories on Earth has shown evidence that human beings can traverse between branches of cosmic history. The multiverse, where it appears in serious physics, remains an interpretive or theoretical possibility, not an observed transport network. The reason it persists is not because evidence is overwhelming, but because the structure of some theories leaves room for realities larger than direct observation. That room is enough for speculation, but not enough for certainty. Even so, the multiverse carries a peculiar advantage in the mystery of future visitors. It offers an answer to the silence of the present that is almost invisible by design. If travellers to the past usually end up in alternate branches, then the absence of obvious visitors in this exact timeline says very little. Time travel could occur elsewhere, endlessly, without ever altering the branch now being experienced in a conspicuous way. History here remains apparently untouched because interventions mostly create or enter neighbouring timelines rather than fold back into this one. The missing visitors problem then weakens dramatically. It no longer asks why no one comes. It asks why anyone would necessarily arrive in this particular branch at all. Across a multiverse, countless timelines may diverge through acts of intervention, but each branch experiences itself as the original. Each sees its own continuity and may detect little evidence of traffic from other histories unless something leaks across the boundary. That thought is eerie because it transforms absence into ambiguity. A quiet timeline is no longer evidence that no one travels. It may simply be one branch among many, distinguished only by not having been dramatically intersected in a visible way. This leads to perhaps the most haunting consequence of the multiverse solution. Identity itself begins to blur. If there are many branches, then there may be many versions of each person, each shaped by slightly different outcomes. Perhaps most of them never diverging enough to be recognizable as strangers, some diverging profoundly. A traveller entering another timeline may meet not a completely alien world, but a world that is disturbingly familiar. almost identical but not quite. The road bends slightly differently. A scientific discovery happens earlier or later. A city skyline carries one missing tower or one extra one. A relationship never forms, or forms under altered circumstances. The traveller becomes both visitor and double, carrying memories that belong to one history into another, where those memories point to events that never occurred. In that setting, the phrase seeing the future acquires a new fracture. Which future is being seen? The future of the departure branch, the future of the destination branch, a probability cloud of futures, some close, some radically different. The very word future becomes unstable once plurality is admitted. There is not one approaching time but a spread of possible continuations, some perhaps inaccessible, some perhaps reachable only by acts that also generate them. The multiverse therefore saves paradox by multiplying uncertainty. It removes contradiction from the structure of one history and distributes mystery across many histories. This is a genuine resolution in one sense, and an expansion of the problem in another. Paradoxes become easier, but ontology becomes harder. What counts as real? What counts as the same person? What counts as success if changing the past means leaving one's own branch wounded behind? The universe remains coherent, but at the cost of simplicity. There is also a deeper challenge from physics itself. If branching is real, why should a traveller experience continuity across branches at all? Conscious experience in ordinary life follows one track. It does not report a spread of parallel selves. Interpretations of quantum mechanics that include branching do not generally include a way for one branch to send macroscopic bodies into another at will. The mathematics of branching is not a permission slip for travellers. It is a framework for describing how multiple outcomes may coexist without collapsing into classical uniqueness. The leap from that framework to controllable multiverse travel is enormous. It may turn out to be unjustified. In that case, the multiverse remains useful as a philosophical dissolver of paradox but not as a practical machine model. Yet even as a dissolver of paradox, it exerts a strange pull because it reveals how attached human reasoning is to uniqueness. Many paradoxes arise only because there is assumed to be one past and one future. Multiply the possible histories and logic begins to breathe again. The question then becomes whether nature truly contains that multiplicity, or whether the mind is using extra worlds to avoid facing stricter laws in one world. That unresolved tension is what keeps the multiverse half scientific, half spectral. It is not a fantasy in the simple sense. It grows out of real theoretical pressures, but it also functions as a shadowland where contradiction is not eliminated by proof, but displaced into a wider architecture still beyond direct reach. If time travel ever does occur through branching histories, then the future may not be a single destination waiting ahead. It may be a field of diverging corridors, each one consistent, none of them final. The traveller would not master time so much as choose among histories, perhaps without ever knowing whether the chosen path is discovered or created, and the strangest possibility of all would remain quietly in the background. A future visitor standing unnoticed in the present might not come from this future at all. The visitor may come from another branch entirely, carrying memories of a world that this timeline never lives through, and leaving behind nothing more obvious than the feeling that reality contains more versions of itself than it is willing to show. For all the fascination with machines that leap backward through time, the most revealing path may be the quieter one. The universe already contains ways of approaching the future, not by violating causality, but by exploiting how causality actually works. That is where the title question begins to change shape. Seeing the future may not mean standing tomorrow in the same way one stands in a room. It may mean learning that some parts of the future are already encoded in the structure of the present, or that some observers can move into later time faster than others, or that information about what is coming can sometimes be inferred with unsettling precision from the laws that are already in motion. The paradox is not solved by an impossible machine appearing in a flash of light. It is solved, if the word solved can even be used, by recognizing that physics does not treat the future as a perfect blank. It treats the future as inaccessible in one sense, approachable in another, and mathematically shadowed in ways that everyday intuition barely notices. The first and most concrete doorway is relativity itself. Time travel into the future is not a fantasy. It is a measured consequence of motion and gravity. The effect is usually small in human terms, but the principle is real. A clock moving very fast relative to another clock accumulates less time. A clock deeper in gravity accumulates less time. This means that two observers can separate and reunite with unequal aging. One has moved farther into the future of the other. There is no paradox here because no one returns to undo the conditions of departure. And yet something profound has still happened. The observers no longer share the same amount of lived time. One has, in a strict physical sense, seen less duration between common points in history. If the effect is pushed far enough, one observer can leap across centuries while experiencing only years. Science fiction often presents this as a technical trick, but it is deeper than that. It means the future is already accessible along certain paths through space-time. The barrier is not conceptual, it is practical and extreme. A spacecraft approaching enormous fractions of light speed, or a journey close to a powerful gravitational field near a neutron star or black hole, could in principle carry travellers into Earth's remote future while sparing them comparable aging. The engineering difficulties are staggering and the biological dangers are severe, but the logic is solid. One can go forward. That alone changes the meaning of time travel. It is not all or nothing. The road exists in one direction already. This matters because it reveals the first genuine answer to the mystery of future visitors. Maybe the future can be visited only by leaving the present behind, never by returning. In that case, travellers from our future would not appear here because the road does not bend back. The silence of the present would not be evidence against time travel. It would be evidence about its direction. Human beings would then inhabit a universe where one can escape into later ages, but never revisit earlier ones. Such a universe still permits something extraordinary. A person might depart in one century and awaken in another, watching languages shift, coastlines change, and civilizations transform. This is not seeing one's own future by prediction. It is seeing it by surviving unevenly through time, but it also creates a strange asymmetry in human knowledge. The future can be reached physically, but not reported back. A traveller who leaps ahead becomes a witness without a message for those left behind. This is the first clue that seeing the future and telling the future may be fundamentally different phenomena. Physics may allow one while forbidding the other. There is, however, another way physics almost lets the future be seen, and it begins with prediction. Prediction usually sounds too ordinary to belong in a mystery about time. Weather forecasts, orbital calculations, eclipse schedules, planetary motion, the return of comets, the timing of transits across distant stars. All of these are familiar enough to feel tame, yet their familiarity hides how astonishing they really are. They show that the universe is lawful enough for later states to be inferred from earlier ones with extraordinary precision under the right conditions. When astronomers predict an eclipse years in advance, or space agencies calculate a spacecraft's arrival at a distant world, or observatories forecast when a planet outside the solar system will dim its star's light again, they are not guessing vaguely. They are reading the future from the present through stable laws. NASA, ESA, and generations of observatories have built entire missions on this ability. The launch windows of probes, the return of periodic phenomena, the motion of binary stars, the paths of asteroids. All of it depends on the fact that the future is not chaos, it is constrained. The deeper significance of this is often overlooked because prediction is treated as mere usefulness. But in a strict sense, it is a limited form of future sight, not mystical sight, not complete sight, but real lawful access to what has not yet occurred. The more deterministic the system, the clearer the access becomes. The mystery enters when that access meets complexity. Some systems are stable enough to predict for centuries, others become chaotic very quickly, where tiny uncertainties grow until precise foresight collapses. Weather is the classic example. The atmosphere obeys physical laws, yet long-term exact prediction becomes impossible because tiny initial differences amplify. This creates an important distinction. The future may be law-governed without being transparently readable. In other words, the barrier to seeing the future may not be that the future does not exist or that it has no structure. The barrier may be that the present does not contain readable information in a clean enough form for human minds or machines to extract far ahead. The future is there in the equations, but buried in turbulence. That realization changes the emotional tone of the problem. It suggests that time does not need to be broken for glimpses of what comes next to emerge. They may already be present in partial, narrow, system-dependent ways. This is where modern physics and modern technology begin to blur. Artificial intelligence systems, probabilistic models, climate simulations, orbital mechanics, and statistical forecasting all amount to increasingly refined attempts to decode future states from present data. Most of the time they are treated as tools, but conceptually they are something else as well. They are non-mystical instruments for peering ahead. Their limitations are just as revealing as their successes. The more complex the world, the more the future resists exact extraction. Yet resistance is not absence. A storm can be tracked before it forms fully. A star can be known to explode in principle long before the exact moment is knowable. A trajectory can be narrowed. A probability landscape can be drawn. In that sense, seeing the future may be less about certainty than about resolution. The future comes into view not as a single fixed picture, but as an increasingly focused cone of possibilities. Physics allows that cone to be sharpened where laws dominate and blurred where chaos takes over. There is another strange route toward future vision, and it runs through black holes and horizons. A horizon is a boundary beyond which information cannot easily return to an outside observer. Black holes possess the most famous such boundary, the event horizon. To an observer far away, time near that boundary behaves in peculiar ways. Signals from falling matter appear increasingly stretched and delayed. The infalling object seems to slow, redden, and fade. To the falling object itself, however, local time passes normally. This mismatch of perspectives reveals again that time is not universal. Now imagine extreme versions of such gravitational environments. In principle, large time differences can accumulate between observers following different gravitational paths. Someone spending time near an intense gravitational field may return to find that the outside universe has advanced much farther than personal experience suggests. Once more, the future becomes reachable through ordinary physics, but only at extraordinary cost. Black holes deepen the mystery because they show that the universe's most violent objects are also time machines in a limited directional sense. Not machines built by hands, but natural structures where the flow of experienced time and observed time diverges dramatically. The cosmos already manufactures inequalities in time. The human dream of future sight is therefore not imposed on nature from outside. Nature already plays with it at the edge of collapse. Astronomy itself carries another lesson. Every telescope sees the past, but the past it sees helps reveal the future. This sounds contradictory until the scale is understood. By observing younger stages of stars, galaxies, and planetary systems at different distances, astronomers reconstruct how similar systems evolve. The universe becomes a library of times layered across space. One nebula shows star birth, another shows maturity, another shows collapse. Some distant galaxies show how cosmic structure looked when the universe was far younger. By assembling these time-shifted views, science learns not only what has happened elsewhere, but what is likely to happen later here or in analogous systems. The future is inferred from the distributed past of the cosmos. Instruments such as the Hubble Space Telescope and the James Webb Space Telescope do not merely reveal ancient light. They allow astronomers to compare stages of development across billions of years. In doing so, they create a map of becoming. This is an indirect but profound kind of future sight. A star not yet old enough to die can still be understood in light of dead stars already observed. A planetary system still forming can be read against systems that are already mature. The universe hides future behavior in the simultaneous presence of many ages. Space substitutes for time. The cosmos displays its own timeline all at once, though scattered across impossible distances. This is one of the most beautiful and unsettling facts in science. The future often becomes visible not by moving ahead, but by finding examples of later stages already underway elsewhere. This leads naturally to a more speculative threshold. If enough information about a system were available, could its future be known in extraordinary detail? Classical physics once tempted some thinkers toward that dream. If every position and motion were known exactly, perhaps the whole future could be calculated. But quantum mechanics damaged that picture. At fundamental levels, uncertainty is not just ignorance. It is built into the structure of measurement and state. One cannot know all properties with arbitrary simultaneous precision. Outcomes are described by probabilities rather than simple hidden certainties, at least in standard interpretations. This matters enormously for the dream of future sight. It means the future may be constrained without being fully predetermined in the classical sense. Even a perfect observer may face irreducible limits. The universe may not contain a fully readable script of what comes next. Only a lawful spread of possibilities. Here the title question becomes more subtle than it first appears. Seeing the future may not mean watching one inevitable movie. It may mean seeing the contour of probabilities before the scene resolves. There are even stranger hints at the edge of quantum theory, where some mathematical formulations treat time more symmetrically than daily life does. Certain equations work whether time is considered forward or reversed. In quantum electrodynamics and related formalisms, advanced and retarded solutions appear mathematically, meaning influences can be written as if travelling backward or forward in time, though ordinary causal physics selects the forward effective behaviour in the situations observed. Most physicists do not interpret this as evidence that messages from the future are arriving in daily life, but the mathematics is enough to leave a faint shadow. The laws themselves are not always as biased toward the human experience of forward time as the world of memory and irreversible processes suggests. The asymmetry may emerge from conditions, statistics, and boundary states rather than from every local law. This is fertile ground for speculation, because it leaves open the possibility that under rare or extreme circumstances, traces of later states could shape earlier conditions in ways that are subtle but real. Such ideas remain controversial and far from demonstrated, yet they reveal something crucial. Physics does not always draw a simple black line between before and after. Sometimes it draws a structure in which direction emerges rather than dominates from the start. That structure does not hand over the future freely, but it refuses to make the future conceptually empty. Then there is the human brain itself, which complicates the matter in an unexpected way. Brains are prediction engines. They survive by anticipating what comes next. They track motion, infer intentions, prepare muscles before conscious awareness catches up, and constantly project near futures from patterns in the present. Neuroscience shows that perception itself contains prediction. The mind is never passively receiving a single moment. It is continuously constructing immediate expectation. Most of the time, this is too mundane to feel mysterious. A falling cup is expected to hit the floor. A moving face is expected to keep its path. But this ordinary predictive architecture may explain why future knowledge feels so natural in small doses and so impossible in large ones. Human consciousness is built to sample the near future probabilistically. It is not built to access distant time cleanly. The brain lives at the edge of what is about to happen. It is always leaning ahead by fractions, always converting law and pattern into anticipation. In that sense, living organisms already practice a tiny biological form of future sight. It is not paranormal. It is adaptive inference. Yet scale it upward through mathematics, telescopes, and relativistic travel, and a larger picture emerges. The future is not invisible because it has no relation to the present. It is difficult because the relation is often partial, statistical, delayed, or asymmetrically accessible. This may be the real answer hidden beneath the time paradox. The future does not need to send visitors backward to be seen at all. It can be reached physically through time dilation. It can be inferred lawfully through prediction. It can be reconstructed through cosmic comparison. It can be approached as a cone of probabilities shaped by known dynamics. It can even seem to stand almost exposed when systems are simple enough and data rich enough. The deeper mystery is not why the future is totally hidden. The deeper mystery is why it is only partly hidden, why the universe permits glimpses but rarely grants direct access, why it allows forward leaps but resists backward messages, why it lets human beings calculate eclipses and planetary transits with confidence while keeping history's larger turns behind a veil of complexity and uncertainty. The future begins to look less like forbidden territory and more like a distant landscape glimpsed through varying thicknesses of fog. In some places the outlines are sharp, in others they dissolve. And if that is true, then the old time travel paradox may have been framed too narrowly from the beginning. The real question may not be whether a machine can carry someone tomorrow and back again. The real question may be how much of tomorrow is already visible now, written in motion, law, probability, and the curved geometry of time itself, waiting not for a door to be opened, but for a pattern to be read correctly. By the time the paradox reaches this stage, the original question has changed its tone completely. It no longer sounds like a playful challenge thrown at science fiction. It begins to sound like an investigation into a kind of silence. Where are the visitors from the future? The simplest answer remains that there are none. The next simplest is that there can be none. But after relativity, wormholes, causal loops, self-consistency, chronology protection, branching timelines, and the partial visibility of the future have all been allowed into the frame, another possibility becomes difficult to dismiss outright. Perhaps the visitors are not absent. Perhaps they are merely unrecognized. This thought is dangerous because it tempts the mind toward fantasy wherever evidence is weak. It can easily become an excuse to treat every anomaly as proof. That is not what the mystery requires. What makes the idea compelling is not that strange claims exist. Strange claims are endless and usually collapse under scrutiny. What makes it compelling is that a truly successful visitor from the future would, by definition, possess advantages that make obvious detection less likely, not more. The more competent the traveller, the less theatrical the trace. In that sense, the absence of spectacle may not weaken the idea as much as instinct expects. It may even fit it. Human beings are accustomed to searching for dramatic evidence. A machine appears. A camera captures impossible light. A witness describes an impossible figure. History is interrupted in some unmistakable way. But that expectation is shaped by storytelling, not by strategic behavior. A traveler from the future would not be stumbling blindly into an unknown age. Such a person would know the language, the fashions, the habits, the surveillance systems, the blind spots, the myths, the noise level of the period, the ways an anomaly is likely to be dismissed, mocked, forgotten, or buried under distraction. If time travel exists in any mature form, future visitors might arrive with the exact opposite of naivety. They would know how people of this era explain unusual events. They would know that contradictory footage will be called fabricated, that uncertain memory will be treated as unreliable, that digital records can be drowned in larger floods of misinformation, and that the modern world is uniquely suited to hiding reality inside excess information rather than scarcity. In earlier centuries, one unexplained arrival might have become legend. In the present, it might become a passing clip lost among millions. This changes the meaning of evidence. A visitor who wishes to remain invisible does not need supernatural powers. Ordinary competence may be enough. A few minutes spent off camera, clothing bought in advance, knowledge of local transport, familiarity with money, maps, and identity systems, avoidance of hospitals, police, and official registration. Small precautions could collapse the chance of discovery. Even a machine itself, if one exists, need not resemble a shining device. It may use infrastructure already present. It may anchor into fixed hidden sites, or operate through structures invisible except under special conditions. It may leave no enduring artifact at all. The present expects intrusions to look spectacular because it imagines them from the outside. A civilization that actually learned to cross time might design its methods precisely so that arrival leaves almost nothing legible to those not already informed. There is another reason the evidence may remain thin. Future visitors may have little reason to announce themselves. Human imagination tends to assume that any traveller would want recognition, conversation, influence, or at least observation, but a serious historical mission would likely value the opposite. If the past is delicate, if causation is easily disturbed, if branching histories are possible, if self-consistency matters, if the mission is scientific, then concealment becomes rational. The traveller would resemble a field researcher more than a conqueror. The past would be a site under study, not a stage for revelation. Even curiosity would be disciplined by risk. If a single word spoken to the wrong person might alter a chain of events, then silence becomes part of the method. Visitors could exist in large numbers across time and still remain almost entirely undetected, because the rules of engagement would reward blending in, restraint, and brief contact. Under stricter models, they may not even be permitted to make significant contact at all. The silence of the present would then reflect protocol rather than absence. This possibility grows stranger when combined with the self-consistency principle. If the timeline can only contain what already belongs to it, then future visitors who appear in this era may already be woven into history in subtle forms. They do not arrive as disruptions. They arrive as ordinary causes hidden inside ordinary events. A stranger gives the right document to the right person at the right moment. A small piece of information appears from no obvious source. A near accident prevents a larger one. A scientist hears an odd suggestion that lingers for decades. No contradiction follows because the intervention was always part of the timeline. Yet from the inside, no one would know. History would simply feel like history. The traveller would not stand outside the story. the traveller would be one of its unnoticed joints. This is the most unsettling version of the idea because it makes evidence structurally elusive. The more effective the visitor, the more fully the act disappears into continuity. That does not mean every coincidence becomes meaningful. Most coincidences remain coincidences. History is full of chance alignments because large, complex systems naturally produce them. But it does mean that absence of obvious proof is no longer a decisive argument. A perfectly integrated intervention would look like an ordinary event with consequences no one traces correctly. The present may not be empty of visitors. It may be saturated with interventions too coherent to stand apart. There is a social dimension as well. If time travel ever emerges, it is unlikely to be used recklessly by casual individuals wandering into any date that interests them. The power would be too dangerous, too valuable, too unstable, too politically charged. Any civilization capable of it would likely regulate it with extraordinary force. There may be laws stronger than any now imagined. Perhaps not only moral laws, but survival laws. A future society that has learned how fragile chronology can be might treat unauthorized travel the way modern societies treat the release of dangerous pathogens or catastrophic weapons. The result would be fewer tourists than fiction suggests. The past would not become a public attraction. It would become a controlled zone. That again weakens the naive version of the missing visitors problem. The logic that says a future full of time machines must flood the present assumes free and casual use. Real technologies rarely behave that way when the consequences are severe. Nuclear physics does not produce crowds wandering freely through reactors. Genetic manipulation does not proceed without oversight in every context. Access narrows as power grows. Time travel, if real, may be the ultimate restricted technology. The very lack of visitors may therefore hint not at impossibility but at governance. Yet governance alone does not answer everything. Even rare missions across centuries should leave some anomaly, some rumour too sharp to dissolve, some artifact out of place. This is where the mystery often drifts toward archaeology and historical oddities. Popular culture delights in photographs with apparently misplaced faces, objects alleged to be too advanced for their supposed age, legends of strangers who know too much, and accounts of sudden disappearances or inexplicable knowledge. Most of these cases collapse under careful examination. Misidentified tools, restored images, altered context, mistaken dates, or simple pattern seeking explain the great majority. Serious inquiry must say so clearly. The unknown is not strengthened by weak examples, it is weakened. But even after weak evidence is stripped away, the deeper point remains. If future visitors are real and careful, the archaeological record may not preserve them as obvious impossibilities. It may preserve them as tiny deviations from expectation, the sort of things later generations attribute to error, undocumented local variation, or a missing page in the archive. History is already incomplete. Entire populations vanish into silence. Countless artifacts decay. Records burn. Languages disappear. The past is not a perfect surveillance field. A visitor leaving almost no trace would be moving through a landscape already full of gaps. There is also the possibility that the future avoids the present not because it fears damaging history, but because this era holds little practical value. Human beings naturally centre their own time. To those living now, the present feels like a decisive frontier. But from the perspective of a civilization centuries ahead, this age may be studied the way modern scholars study obscure intervals of the past carefully. Yes, but not obsessively. Only certain moments may matter intensely. A breakthrough, a catastrophe, the birth of a key idea, the failure of a system. Future visitors may cluster around events that later ages judge significant. leaving long stretches of ordinary time almost untouched? If so, then looking for visitors everywhere and at all times may be the wrong method. The distribution would be uneven. There may be historical bottlenecks, moments where the timeline becomes especially sensitive. Travellers might appear there repeatedly, while the rest of history remains comparatively quiet. This idea gives the missing visitors paradox a new shape. The absence is not universal, it is selective. The problem is that no one living inside a moment knows with certainty whether that moment is central to future history or merely local and forgettable. Another possibility is more haunting. Future visitors may not appear human at all in the expected sense. A civilization centuries or millennia beyond the present may not send biological bodies into the past. It may send probes, encoded information, remote observation systems, or forms of intelligence designed specifically for minimal interference. The visitor may be small, silent, machine-based, or even distributed through existing communication systems in ways that do not register as presence. This possibility widens the field dramatically. Searching for a person out of time may be the wrong frame. The future may observe through tools almost indistinguishable from the background of modern technology, or through patterns too subtle to separate from ordinary data flows. Again, this remains speculation, but it is grounded in a simple trend already visible in human history. As technology advances, presence becomes less physical and more informational. Observation detaches from the observer. If that trend continues, then future visitation may leave fewer theatrical marks than any older imaginator expects. The past may be watched not by cloaked travellers in crowded streets, but by systems so discrete they resemble measurement rather than arrival. One of the strangest answers to the silence of the present is that history itself may already contain mechanisms discouraging disclosure. A traveller who reveals the truth could produce panic, cult formation, fraud, political misuse, or timeline instability. The safest operation may therefore depend on remaining unidentified even when accidental contact occurs. This would create a peculiar social effect. Genuine encounters, if rare, would be mixed into the same cultural space as delusion, hoax, folklore, and entertainment. The signal would be buried not by perfect secrecy, but by contamination. The truth, if it surfaced in fragments, would resemble fiction too closely to survive. That idea is difficult to prove and impossible to dismiss completely, because modern culture excels at turning anomalies into content before understanding them. A real visitor described in a shaky report would compete with millions of fabricated narratives and would likely vanish among them. The future would not need to silence everyone. It would need only to rely on the present's own noise. This brings the paradox close to the Fermi-style question, often asked about alien civilizations. If the universe may be full of life, where is everyone? The future visitor problem has a similar structure. If time travel becomes available, where is everyone? In both cases, absence may point to impossibility, rarity, danger, self-destruction, deliberate silence, observational limits, or wrong assumptions about what present should look like. The analogy is imperfect, but it is useful because it reminds the mind how many explanations can hide behind a quiet sky. Silence is never a single fact. It is a field of interpretations. Some are conservative, some are strange. All are constrained by the same problem. Evidence is sparse because whatever is being sought is either truly absent or adapted to evasion. The present therefore sits in an awkward position. It knows enough physics to understand that time is not simple, enough history to know records are incomplete, enough technology to see how visibility can fail inside overexposure, and enough imagination to suspect that the clearest sign of visitation would not be spectacle, but unnaturally perfect ordinariness. A person appears, passes, influences, vanishes. No machine is found. No contradiction emerges. No one realizes a foreign future just brushed against a familiar day. That image is impossible to verify, and that is part of its power. It fits too easily into the cracks of reality, yet it does not arrive from nowhere. It arises from following the logic of the paradox to its quietest conclusion. If time travel is real, if the past is reachable, if interference is risky, if serious missions favor concealment, if history is already full of noise, then the most plausible visitor is not the obvious one. The most plausible visitor is the one no era knows how to name while the encounter is happening. And so the absence that begins as a challenge may end as something harder to read. It may be a genuine void, or it may be camouflage, not applied over history from outside, but woven into the way history already looks from within. By now the paradox no longer belongs to one question. It begins with future visitors and ends by challenging almost every ordinary assumption about time, causation, history, identity, and knowledge. The deeper it is examined, the less it resembles a single unsolved puzzle, and the more it resembles a boundary line in thought, a place where the universe starts revealing the limits of human intuition. This simplest version asks why no one from the future is clearly here. The later versions ask whether anyone could be here, whether history would allow itself to be changed, whether change would merely create another branch, whether the universe blocks contradiction before it forms, whether the future can be seen without being reached, and whether the silence of the present is evidence of impossibility, or merely evidence of methods too subtle to notice. No answer has fully defeated the others. Instead, each answer has exposed a different shape the universe might have. In one shape, time travel is impossible because nature protects chronology so completely that no machine can ever turn the road backward. In another, the road does turn backward, but only through self-consistent loops where every event already belongs to the history it seems to alter. In another, the paradox never forms because every intervention enters a different timeline. In still another, the future is not visited physically at all, only approached through relativity, prediction, probability, and the slow sharpening of pattern. The mystery remains because each of these possibilities is partly grounded and partly uncertain. None is empty fantasy. None is established fact. That is why the question endures. It rests exactly where human knowledge is strongest and weakest at the same time. It draws energy from real physics, and from what real physics has not yet unified. General relativity makes time flexible. Quantum theory makes certainty incomplete. Thermodynamics gives time an arrow through increasing disorder. Cosmology shows a universe with a beginning in a hot, dense state, and an expansion that carries structure outward over billions of years. Observation confirms that clocks disagree under speed and gravity, that light preserves the past, that black holes exist, that space-time is dynamic, and that the observable universe is stranger than earlier ages ever imagined. Yet these same triumphs leave unresolved the deepest union of the laws. Gravity and quantum mechanics still resist a final reconciliation. The mathematics of possible spacetime structures remains larger than the catalogue of structures nature has clearly realized. The future is law-shaped, but not fully readable. The past is recorded, but not perfectly preserved. Human understanding therefore reaches an edge where serious speculation becomes unavoidable. That is the zone where time paradox lives. It is not a failure of science. It is a sign that science has reached terrain where every clean answer demands a deeper map. One of the most revealing outcomes of the paradox is that it changes what is meant by solving it. At first, a solution seems as though it should be a declaration. Time travel is possible or impossible. The future can be visited or cannot be visited. Visitors are here or are not here. But as the frameworks accumulate, resolution becomes more subtle. A paradox can be solved by proving the machine can never exist. It can be solved by proving that only self-consistent histories are physically allowed. It can be solved by showing that any apparent contradiction is merely a branch crossing. It can even be partly solved by recognizing that the strongest human desire behind backward time travel may be misplaced. Because the universe already offers weaker but real forms of future access, while refusing the dramatic reversal the imagination prefers. The title question therefore starts to open from inside. How might the future actually be seen? Through unequal aging, through lawful prediction, through the astronomy of delayed light, through probabilities that narrow before events arrive, through examples of later cosmic stages already visible elsewhere, through history shaped by constraints that make tomorrow partially legible today. The answer need not be a tunnel in time. It may be that the future is never totally hidden in the first place. It may only be hidden unevenly. Yet even that more restrained answer does not exhaust the mystery. The dream of actual temporal return continues because forward vision is not the same as backward contact. To know that an eclipse will occur is not to stand inside the century after one's death. To infer the fate of a star is not to witness one's descendants looking back. To move into the future by relativistic drift is not to send warning home. Human longing inside the paradox is not just for knowledge, it is for relation. The wish is to cross the barrier and remain connected on both sides. That is the part the universe seems most reluctant to grant. This reluctance may be the most important clue of all. Perhaps time is not merely another direction because identity itself is built from a symmetry. Memory points one way. Records accumulate one way. Organisms develop one way. Causes become effects in one lived order, even if the deeper equations sometimes look more symmetrical. The universe may allow geometry to fold and clocks to disagree, while still preserving a larger directional integrity that prevents full two-way travel. If so, paradox is not an accidental inconvenience. It is a sign that lived reality depends on the one feature human beings are most tempted to violate. The arrow of time may not be an illusion in the crude sense, even if the present is not absolute. It may be an emergent discipline, a global pattern that countless local laws conspire to maintain. That would explain why time can stretch but resist reversal, why information about the future can be inferred but not casually received, and why the past feels so physically near through memory and record yet remains unreachable as a place to be re-entered. Still, the paradox refuses to end there because the known laws do not close the door completely. Wormholes remain hypothetical, not forbidden by simple common sense. Closed time-like curves remain part of some mathematical solutions. Quantum theory continues to challenge everyday intuitions about causation, state, and possibility. The multiverse remains speculative but not meaningless. No completed theory has yet arrived to say, once and for all, that all routes backward are illusions. The case against backward time travel is powerful, but it is not absolute in the way the case against square circles is absolute. Time travel belongs to a rarer category. It may be impossible, yet for reasons that must be discovered rather than assumed. That distinction matters. The universe has already overturned too many confident instincts for this one to be dismissed casually. There was a time when bent space, black holes, gravitational waves, and worlds around distant suns seemed far removed from reality. Nature has a history of being more inventive than intuition. That does not mean every speculation becomes true. It means certainty must be earned. Another revealing consequence of the paradox is that it changes the status of absence. At the beginning, the lack of obvious future visitors seems like an argument. By the end, it becomes data that can fit multiple models. No visitors may mean no machine. It may mean forward-only travel. It may mean chronology protection. It may mean tight regulation. It may mean branching timelines. It may mean that the machine has not yet been built in the reachable past. It may mean that visitors are present but too careful to notice. It may mean that the future interacts with the past not through bodies, but through information, probabilities, constraints, or hidden observation. Silence has not disappeared, but it has become ambiguous. This same empty stage can support many unseen architectures. This is why the paradox continues to feel alive, not because it lacks answers, but because it has too many structurally possible answers waiting on deeper evidence. Even the word future has changed by this point. It no longer means a single blank region approaching uniformly. It may mean a destination reached at different rates by different observers. It may mean a branching set of continuations. It may mean a spread of probabilities. It may mean a region of a larger spacetime structure not yet intersected by present consciousness. It may mean the later states already implicit in current laws. Once the future becomes plural in this way, the phrase seeing the future also becomes plural. It could mean prediction. It could mean physical survival into later centuries. It could mean receiving information from a loop. It could mean entering another branch where later conditions already exist. It could mean observing distant cosmic examples of what is coming to one's own system. The old dramatic image of time travel begins to dissolve into a family of lesser and greater access modes, some real, some speculative, some perhaps forever out of reach. And yet the emotional centre of the mystery remains strangely stable. It is still about the relationship between knowledge and irreversibility. Human beings are creatures who remember the past and move toward what they cannot fully know. That asymmetry defines fear, hope, regret, planning, science, and story itself. A machine that truly crossed time would not just add a new vehicle to civilization. It would attack one of the deepest conditions under which civilization thinks. No wonder the universe seems reluctant to allow it. Or perhaps no wonder the universe only allows versions of it that preserve the structure of consequence by other means. The paradox, therefore, may not be a flaw in the idea of time travel. It may be the fingerprint of reality pushing back against a misunderstanding. The misunderstanding is that time is a sequence of rooms through which a sufficiently clever species might wander at will. Everything modern physics has taught suggests something more demanding. Time is entangled with space, motion, gravity, entropy, and information. It may be locally flexible and globally disciplined. It may allow partial access and forbid full reversal. It may contain mathematical corridors that physical law later seals. It may harbour many histories or only one history, so rigidly self-consistent that any attempt to break it merely reveals its hidden strength. In that light, the original question remains valid but incomplete. Where are the visitors from the future? Perhaps nowhere. Perhaps everywhere they have always already been. Perhaps in other branches. Perhaps still impossible because the final law that forbids them has not yet been discovered. Perhaps already present in subtler forms than bodies stepping from machines. Perhaps the most honest answer is that the paradox has not been solved by removing the mystery. It has been solved only in the sense that the mystery is now sharper. The future may not be invisible. It may be visible in fragments, reachable in one direction, encoded in law, and hinted at by structures that almost permit more. But the full exchange between times, the clean loop of departure and return, remains suspended between mathematics and silence, and that suspension may be the clearest clue. It suggests a universe that is not indifferent to chronology, yet not simple enough to be understood as a straight line either. A universe where tomorrow casts shadows backward in prediction, where distant galaxies preserve vanished ages, where clocks part ways under motion and gravity, where equations almost fold history, and where one unanswered question keeps returning with greater force the longer it is studied. If the future can ever truly be seen, perhaps it will not arrive first as a machine, but as the realization that the boundary between what has happened and what is coming has never been as solid as it feels while living inside it,